All right, so we're on 3C.9, inverse trig functions, okay? So as far as this goes, it's not terrible. It's fairly simple. So as with all functions, the inverse of a trig function is a result of switching your input of your x and your y, right? Every function has an inverse operation, correct? So when we had our square, our power is a radical, our exponential is a log. Every function has a inverse, okay? As a result, the output value of an inverse function will be the angle measure. So if I'm looking for the angle measure, like I have the trig ratio, but I want to know what is the angle measure, I use the inverse of it, okay? There are two ways that you may see inverse. So way number one that you may see the inverse being represented is as just sine inverse. This does not mean sine to the -1. It means sine inverse. It's just a notation for it. But when you see sine power of -1, it's more of a subscript versus it being an exponent. Does that make sense? So this means inverse. You also may see it as arcsine or arctan or arc cotangent or arc anything. But these are the notations that we'll see, okay? You either can say inverse or you can say arc. Most of the times, especially if you're in a college level math or physics class, they're going to say arc. So they'll say arc sine, arc cosine, arc tan. So just make sure you understand that it means that you are looking for the inverse. You're looking for the angle that made that ratio, that made that value. All right. So let's start with an example. So here we have the statement sine pi over 6 equals 1/2. And we're going to write it as a inverse notation, arc sine notation. So when I'm writing this, I'm writing it as, okay, sine inverse or arc sine of 1/2 equals pi over 6. Does that make sense? So this is telling you that you are switching your x and y. Your input becomes your output and your output becomes your input. Or you may see it as arc. That doesn't look real pretty. Arc sine of 1/2 equals pi over 6. Okay. That's all that means, is that you're literally switching your input and your output. So the moment you switch these two guys, that's the moment you have to change from sine to arc sine, and vice versa, not vice versa, also with cosine, tangent, and all the others. All right. So how does this work as a function, as a graph? How does this function work as a graph? So there's going to be restrictions when you think about it. So if we look right here with our sine function, we know the sine because it starts off as a snake at the origin. Do we see our sine, our positive sine function? Try that again. I swear I went over, pretend that is, yep, there it is. All right, there's our positive sine function. If I'm looking for the arc sine, the inverse of that, that means that at every point I'm switching my x's and my y's around. Does that make sense? Because I'm switching my x's and my y's, what happens at my x-intercepts? They are at the pi 0, it's now going to become what? It becomes 0 pi. And you have multiple x-intercepts. So you're going to end up with multiple y-intercepts. Are you able to have multiple y-intercepts? No, you can't have multiple y-intercepts. So what ends up happening is that there's restrictions on our inverse. Does that make sense? There are going to be restrictions placed on our inverse because of that. So when we are talking about our inverse, sorry. Did it go into the other page? Yes, sorry. On my notes, it went over. We're up here at this part. Okay. In order to talk about the inverse of the function, we have to restrict our domain. Okay. So when we're looking at our function, we're restricting it to only look from negative pi over 2 to positive pi over 2. Because if we don't restrict it, what's going to end up happening is that we're going to have multiple y-intercepts. And are we allowed to have multiple y-intercepts? No, we're not. So when you are looking here at the sine function, we're only analyzing our inverse from here to here, because that's the piece where it is 1-to-1. It passes the vertical line test and the horizontal line test, meaning that there are no repeating x's and there are no repeating y's, okay? And so this is why we only analyze from here to here. Because now, can I switch all of the x's and y's on this interval and it create a function? Yes. I can't do the entire function. I have to do it piece by piece. So this part goes down there too. This also applies with cosine. I don't know how, but it should have been at the bottom of your page. So just make note that this is talking about the arc sine and the restrictions of it. So the domain is only from negative pi over 2 to positive pi over 2. The same goes for cosine. If you look at our cosine function, our cup here, we have two x-intercepts, right? So if I was to use from 0 to 2 pi as my domain, I would not create a inverse function, right? That's because I have two intercepts taking place. So we would only analyze again from negative pi over 2 to positive pi over 2. The difference here, though, is we do not include both in behaviors. So if you look at the sine function, it's included, right? So your negative pi over 2 and your pi over 2, those are included values. When you look at your cosine function, they are not going to, I'm sorry, I did that wrong. I lied, because that is not one-to-one. She's tripping. She's tripping. And again, why do people watch my videos? I do not know. I lied. It's from here to here. There we go. Sorry. It's from 0 to pi so that you're not repeating. Therefore, it's a one-to-one function. We're not supposed to say this in AP Precal, but it passes the vertical line test and it passes the horizontal line test. What we're supposed to say in Precal is that our input and our output values do not repeat, right? They are one-to-one situation. But in our mind, visually, we can see that it passes the vertical line and the horizontal line test. Okay? And so it's defined from 0 to pi. So sine is from negative pi over 2 to pi over 2 for arc sine. And then arc cosine is going to be from 0 to pi. Is where we're going to have to restrict our cosine and our sine functions. And then we're going to switch x's and y's. And we're going to look at that here in a minute. Tangent. Tangent's domain is restricted already because it has those asymptotes. And we're going to just stick where those vertical asymptotes start. And that's going to be from negative pi over 2 to pi over 2. And I did not put it tangent graph because I don't know why. We'll figure that out later. All right, so let's talk about what does that mean when we're looking at it from the unit circle. We're only using certain quadrants. Does that make sense? So looking at the unit circle, we're only going to be using certain quadrants because we're from this to this. So when we're looking at the unit circle for inverse or arc sine, we're going to only be using quadrant number 1 and quadrant number 4. Okay, so we're only using 1 and 4, but it's not a pin. Okay. For inverse cosine, we're using 1 and 2 because it's from 0 to pi. And then for inverse sine, we're also using 1 and 4 to help us define our angles. These are going to be the angles that help us figure out our reference angles to know where we're going because obviously there could be more angles. But these are where you're going to focus on. How I remember sine and tan are the same is that when you think about tangent, when you have the tangent, that sine is in the numerator. So sine is the dominant one, right? So it's going to follow whatever the dominant function is doing, is what I told myself. So sine and tan are going to follow each other, and cosine is the denominator. So it's going to be the opposite. At no point, as you can see, we do not use 3. Okay. So let's talk about how this would look on a non-calculator part. Okay. On the non-calculator, it's expecting you to use your unit circle. Remember the first thing I said that you're going to do when you get your test is on your scratch paper, what are you going to create? Your unit circle so that you don't have to keep thinking about this throughout the test. It will already be written down on your paper. Does that make sense? So the first thing your brain should do is vomit out your unit circle. All right. Once that's done, now you're just going to be referencing back to your unit circle in order to answer these questions. All right. And when we do this, we want to think about things in terms of X's and Y's, okay? So when we're looking at the inverse here, you're asking yourself at what point does, if I have cosine inverse, you're looking for the X's. If I have sine inverse, you're looking for the y's. And if I have tan inverse, remember that's applying y divided by x. What angles have these values if I do this? Okay, so let's start here with cosine inverse. Inverse. So it says negative square root of 2 over 2. So I'm looking for when x equals negative square root of 2 over 2. That's all it simply is asking you. So on the unit circle, we know that cosine is positive in quadrants number 1 and in quadrant number 4. So therefore, it's not in quadrant 1 and in quadrant 4, correct? So we're going to be going to quadrant numbers 2 and 3. So looking in quadrants 2 and 3, when do I have an x coordinate that is negative square root of 2 over 2 in those two quadrants? So again, we're looking in quadrants 2 and in quadrant 3, and that's going to be what? Your x value being negative square root of 2 over 2. Let me open up my unit circle so we can look at it together.